This is an example of an electric circuit. Electric circuits all contain the same three basic parts: an input, which is the battery. All circuits have wires, which conduct electrical energy. And all circuits have an output. In this case, it's a bulb. Now this circuit is an open circuit. You can see that none of the pieces are attached. In order for electrical energy to flow in an electrical circuit, the circuit must be closed, or a complete loop. Because the parts of this circuit are open, this is an open circuit. This circuit does not function. In a moment, we'll look at a complete circuit with a closed loop. Here's an electric circuit with an input, which is the battery, the wires that we saw previously, and the output of a bulb. Now this circuit is open. The wires do not connect to the battery. Energy cannot flow. When I close the side and close the circuit, electrical energy can flow through the wires to the bulb and back. It's a complete loop. An electric circuit requires a complete loop in order to work. If the output was sound, for example, or an electrical motor, it would operate the same way. If the circuit's open, the circuit doesn't work. When it's closed, it does. Just a heads up, when you're working with this particular electric circuit using an LED bulb, the LED bulb has to be on the copper tape in the right way. You'll see that in this case the circuit's closed, but the red bulb is not lighting. If it's not lighting, flip the legs, those two metal pieces, around, and it should light up. Again, it does matter which of the metal pieces lands on which piece of tape. So if your bulb doesn't light, pick it up, flip it over, try it again, and now as long as everything is connected properly, your LED bulb should work. Check to make sure you've got all the pieces, the battery, two wires, and the LED bulb. You'll also need Scotch tape. Now we're ready to begin. We're going to go ahead and start by peeling the back of this copper tape off. It's important that you put the copper tape on the lines that are shown on your paper. It doesn't have to be perfect, but it should be flat, smooth, and inside those lines. It's okay if it's off a little bit, but it needs to be close to those lines. Make sure you don't wrap the copper tape up or bend it. It should be flat and smooth. Notice how I've got my two wires right on those lines. Now we'll place the battery right on that circle. Notice how I put the battery on the circle, and I'm going to put a piece of tape on top of the battery, but only covering half of the battery. Let's take a closer look. Notice that the tape only covers the top half of the battery and does not cover the bottom half of the battery. Also, make sure that battery is not touching the bottom piece of copper tape. Now we can go ahead and fold the paper over, and that's going to close the circuit by putting that bottom piece of copper tape onto the top of the battery, and we can try lighting the bulb. Remember, if the bulb doesn't light, flip it over, and now it should light up. Make sure you leave it there carefully. Again, if it doesn't light and everything is closed and looks good, flip it over. Make sure it lights and then leave it there. And now we're going to tape on that bulb, making sure that the metal legs of the bulb are taped directly to the copper tape that we're using. Let's check that connection. You can see the top leg of the bulb is taped to the top wire, and the bottom leg of the bulb is taped to the bottom wire. Now when we close the circuit, the bulb will light. We have a closed circuit, a complete loop through which energy can flow.